Hello everyone, welcome back to my channel. In this video, we'll be solving another FAANG DSA question, which is product of array except self. It is problem number 238 on lead code. So let's start off by understanding the question with an example. Imagine you're given an array 1, 2, 3, 4 nums array as an input, and I ask you to create a new array where every position contains the product of every other number except itself. So the answer should be this array. As you can clearly see, if we leave out the element at 0th index, that is 1, and multiply all the other elements, that is 2, 3, 4, it gives us the result 24. So in the output, I'll be keeping 24 as the 0th input. Similarly, for index 1, I'll be hiding 2 and multiplying the other 3, 1 into 3 into 4, which gives us the result 12 for our index 1. Moving on to index 2, I will hide 3 and do a product of 1, 2, 4, which gives us 8 at index 2. Similarly, for 6, I'll leave out 4 and multiply 1, 2, 3, 4. I'll be getting 6 at index 3. Sounds easy, right? Most people immediately think just multiply everything together and divide by the current element. And honestly, that's exactly what I thought too. So let's give it a try. If I multiply every element of this input array, I'll be getting 24 as my total product. For index 0, if I divide 24 by 1, I'll get 24 again. Again for index 1, 24 divided by 2, I'll get 12. Once again, 24 divided by 3, I'll get 8. I'll be dividing 24 by 4, which will fetch me 6. Except lead code says you may not use division, meaning you can't use the division operator. With that, let's think differently. For every index, if we loop through the entire array and multiply everything except the current element, that works. But for this, we'll be needing a nested for loop where actual operation would take place in the inner for loop and the outer for loop would have the task of keeping the record of the current index if the array has n elements and we are doing roughly n cross n operations in this. And that's big O of n square time complexity. And lead code won't be impressed by it. So now we are stuck. No division, no brute force. What's left? Here's where the real trick appears. Let's focus on just one position. Take the number 3. What do we actually need? We need everything to the left of 3 and everything to the right of 3. That's it. For every position, the answer is simple. Product of all the arrays to the left, product of all the arrays on the right. Suddenly, the problem looks completely different. Instead of calculating the answer directly, what if we pre-calculate all the left and right product? For our example, the left product would look like this. For before index 0, there's nothing. So I'll be placing 1 for that. Before index 1, we have 1. 1 cross 1 gives us 1. Before index 2, we have before index 3 equals 6. Now for the right product, we'll be doing the same thing from the backward side, from the last index. Before the last index, we have nothing, so I'll be keeping 1. Before index 2, we have 4. Just like this, the calculation goes on, and I'll be getting this right product array. Now, since we have got our left product and right product, this is where the magic happens. Multiply corresponding positions. 1 into 24, 24. 1 into 12 gives us 12. 2 into 4 gives us 8. 6 into 1 gives us 6. And this is exactly what we wanted. And we have achieved it without division. So we have reduced the time complexity from big O of n square to big O of n. And the space complexity would also be big O of n. But wait, can we do even better than this? We can have an optimal solution. What if we use only a single array auxiliary space to reach our output? In short, I'm trying to optimize my space complexity from big O of n to big O of 1. So for this, I would have to remove the dependency on these two product arrays. What I'll be doing, I'll be performing my entire operation on this result array and it will store our answer which will be returning. So it is a two-step process. First of all, I'll be performing a forward traversal from left to right and store element in it just like we did with this left product subarray. So this was the first step. In the second step, I'll be taking a variable Let's name that as right product and I'll be initializing it with 1. Now I'll perform a backward traversal from right to left, and in each iteration I'll be first multiplying the right product with my current element and then updating the value of right product by multiplying it with the current value in the nums array. Alright, so this is the entire logic that we're gonna follow. Let's code it up and you'll have a clear understanding that what am I talking about. I'll start off by creating a variable n, which will be storing the length of my nums array. Then I'll be creating a result array, which will be the hero of my entire solution. So as we discussed in the slide, first of all, on the left side of the zeroth index, we are having nothing. So I'll be initializing the result at zeroth index as 1, followed by a for loop for traversing the nums array from left to right. I'll be starting it with 1. Why with 1? Because at zeroth index we have already assigned a value 1, and we calculate the product from the left side one element before the current element. That's why I'm taking I equals 1. Inside this for loop, I'll be keep on calculating and storing the product of all the leftmost elements at ith index. This is how I'll be doing that. Result till I minus 1 multiplied by element at the index I minus 1 in the nums array. Now I'll be declaring a variable right product, and as discussed in the slides, I will be initializing it with 1. Now traversal would take place from right to left, starting with n minus 1 till n is greater than or equal to 0, increment operator, decrementing it one by one. So remember, in the second step, we perform two operations. First of all, in the first operation, we used to multiply the right product value with the value at current index in the result array. That's how we'll be doing that. And in the second operation, we'll be updating the value of right product. I'll multiply the current value of right product by the current index value of nums. So basically this step is preparing the ground for the next iteration of this for loop. After this entire operation is performed, I'll be simply returning my result. So our solution has passed all the test cases. So this was all from this video. See you in the next video.